All right, here we are. Welcome to my stream. It's been a while, but I'm here again. So there's already a couple of people in the chat. Hello, everyone. Somebody commented on my interrupted screen, which is this one here. Um, and they suggested assert Erno must be more than 0, which, fair enough, but don't use asserts. It results in ugly error messages. All right, and then mdlayer wrote, if you ever decide you want to run several router 7s and add OSPF version 3, I should have a Go package for you in a few weeks. Which, yeah, is pretty cool. I've seen you start the work on that on stream. Um, okay, yes, I suppose that's one way to do the ugly error messages. Yeah, the OSPF stuff, I currently only have one router 7 installation. Typically we do, I want to say, a portable one for an event that we do once a year, but it's not currently happening due to travel restrictions and such. So yeah, maybe. I think it's pretty cool. One thing that I would want to address first, which let me just take control of this browser right here. So, oh yeah. All right. To give some context around this, so router 7 is a Go implementation of a small home internet router. So it's kind of like the box that your internet provider gives you, but it's all self-built and in Go. And one thing that I would want to address first is we have a couple of open issues that are even tagged as good for stream for WireGuard integration, which I know you've been working on as well, where we could route all traffic through a WireGuard tunnel for this particular portable installation so that all of the traffic is sent to my home internet connection. Or there's the opposite use case of just connecting external computers into the home network and not just routing traffic through the router 7 instance. These two, I think, would be cool to tackle first, also to gain an understanding of how routes work. I know much of the theory, but it's been a long, long time since I've ever had to configure routes. So that'll be a good refresher. And then afterwards, I think we can think of a protocol such as OSPF, which adds another layer of complexity on top of the routes. I don't have a major routing protocol needs at my house, but it's fun and I'm learning. Yeah, absolutely. I just like to work on use cases that not only are fun to learn, but also have something to help in my practical day-to-day life. So that's why I'm a bit hesitant or steering my efforts towards these first. But learning is always fun. So you go. That's my general rule too. Nice. All right. Okay, so let's dive into one of the issues that I thought would be fun to tackle on stream today. And please interrupt me if you have any questions. So this is the setup that we're working with today. I have a capture card here to which a Raspberry Pi is connected. I'm gonna switch over to the capture here. You can see that there's some error messages going on the Raspberry Pi, which is not great, but I don't know why they started happening. They didn't happen earlier, so these are the demo gods for you. But for the purpose that we want to see it is just to see the log when it's booting up in case we do something to screw with our boot process, which is actually one of the later issues for today's stream if we get around to it. So this is the Raspberry Pi it's running. It's running a project of mine called gokrazy, which this is the logo of. I can show you the website at gokrazy.org. So with gokrazy, you can put your Go programs onto a Raspberry Pi, and you don't have to install, Raspbian or Debian or Arch Linux or any other Linux distribution of your choice. Instead, what gokrazy does is it bundles the Linux kernel, the Raspberry Pi firmware, it uses the Go compiler and its standard library, and then whatever else you put into your command line. And let me show you how this could look like. So we have a gokrazy packer command line here where I'm updating the existing Raspberry Pi system that I have here. I'm putting the Hello World package on it. I'm putting the break glass package on it for interactive debugging. There's a serial busybox version that is pre-compiled and you can use to have a shell on your serial console by default. That's not going to be much use here because we disabled the serial console. Then I added an MQTT broker called HMQ. And I have this little package here called gdns, which is what we're going to work on today. So this is sort of the top level hierarchy of where this all fits in. So let's talk about gdns specifically, and then I'm going to show you what it does. So the overview says gdns sets up router 7 dynamic DNS entries for transparent proxies to make gokrazy processes available under a name instead of a port number. So this is pretty cool. If, for example, you have the timestamps package, which actually, let me just add this because it makes for a nice example. So we could just reproduce what is here in the README, and you can get a feel for how this all looks and feels like. So I have this command line here where I'm adding the timestamps package, which previously I hadn't installed on the Raspberry Pi. Let me also add ping in another window. So now you can see that it's using the Go tool to fetch the timestamps package. It's compiling the gokrazy image. Don't worry about this password, it's a throwaway. Then it sends the update to the gokrazy instance. You can see that it's reaching quite good speeds here of over 60 megabytes per second. This is not on an SD card on the Raspberry Pi, but it's on a USB stick that I'm booting it from. Which is one of the nice features of the Pi 4. You can boot it from USB devices easily. So then it says updated, should be back within 10 to 30 seconds. And we can see on the right here that indeed there's about 30 pings in between here, between the device going off the network and coming back. So now we can go back and access its web interface. And we can see that we now have the timestamps package running here. Timestamps is a small program which reads the build timestamp of the boot partition and the root partition. It shows here the raw Unix timestamp values, and then here the decoded time values. And we can see that the gokrazy build timestamp itself is also embedded here. So that would be the 160637, and that matches the root here. And timestamps also exports all of this via a web interface for Prometheus scraping. So instead of just accessing gokrazy on port, well, what port? We don't really know what port because it's not printed anywhere here, right? But gdns figures it out. It says timestamps, the program has one port, and it encoded it as 53D, which, if we take a look, that's 1341 in decimal, so that's the port number. And if we go to gokrazy on port 1341, we get a 404 page not found. But we do have the /metrics endpoint for Prometheus, and here we can see the timestamps of boot and root. Okay. So what gdns now adds to this picture is that you don't need to use the port number, but you can use timestamps.gokrazy /metrics, and then you have the same result. You see the same page. So the request is being forwarded, and you can use these nice descriptive speaking DNS names instead of remembering port numbers. All right. People are talking about Metal LB in the chat. Maybe add a link to the chat if you can for people who are unaware of what it is. Don't run Kubernetes at home anymore. That sounds like a good idea. Good morning to you too. And then OSPF, Bird, Quagga. Yeah. Network stuff going on for the network geeks. Nice. I'm going to continue over here with my own spin on this networking stuff. So yeah, this dynamic DNS networking is kind of similar to, I want to say, service discovery, except it's in our home network. Hey Christian, how are you doing? It's like on a much smaller scale, right? So behind the scenes, we can look into what gdns does. It requires a little bit of setup on your router 7 because it uses an IPv6 ULA network in which it adds IP addresses and then listens on them on port 80, which is why we can get the nice host names without an extra port. And then it forwards internally to the port that it figured out your other processes running on the computer, in this case on the Raspberry Pi, are listening on. You can see here the code that we have for figuring out the listening addresses. And then let's see here. Oh yeah, so this is iterating through /proc to find the processes. And then, oh yeah, to figure out the command line, to figure out the binary name. And then that's what's being added to the dynamic DNS setup. Right. It's been quite a while since I've last touched this. It says March 2019, so I'll need a refresher as much as you need an introduction if you haven't worked with this before, which is unlikely because it's a very, very specific piece of setup. You know, you need to be using gokrazy and router 7, and I think there's only like, maybe not even MedLayer does it, so there you go. All right, so let's see. The issue that we want to address today is that gdns works fine, but it only works fine when it starts up. And when the other processes are not yet running, maybe because they're still waiting on some resource and are restarting, a manual restart will be required to pick up all of the addresses. And in fact, I think if you've paid very close attention, you can already see that timestamps has been forwarded, but there's more processes running on this particular installation. There's also the HMQ MQTT broker, which it's listening, but it needed a while to come up. So gdns wasn't running back then. And if we now restart it and refresh the status page, we'll see that not only has it captured timestamps, but also HMQ and HMQ.2. But after rebooting the whole installation, the HMQ entry is kind of missing. So because I update all of my Raspberry Pis every day, it's kind of annoying that some of these entries are missing. So that's what we're going to work on today. Router 7 is super cool, but I'm pretty invested in my NixOS setup at this point. Yeah, fair enough. I figure, you know, the amount of time people typically need to get NixOS set up just right is kind of like getting Emacs set up just right. And at that point, you're very invested. 2 years and still working. Gotta love that backward compatibility of Go. Yeah, absolutely. In fact, I think I have code from 2009 that is still running untouched and working. Or Arch Linux. Yeah, for Arch Linux, I think, you know, they have an installer now. Have you tried it? I haven't had a chance to try it. But, you know, with an installer, there's not really much to setting up Arch Linux. No, that's what people are screaming. I actually welcome the installer. I think it's silly. Yeah, it's not officially supported, but I think it's silly to have people install it manually. I mean, it's nice that they describe how it works, but I don't want to necessarily have to do that for every installation. Not officially supported yet. That's promising. All right, keep up the good work on this. All right. Cool. So yeah, gatekeeping is bad, and anything that reduces barriers to entry is a win. Yeah, fully agreed. Okay, so first of all, we're gonna git clone gokrazy gdns. And then we're gonna go over to the go.mod file here, and we're gonna tell it that instead of using gokrazy gdns, it should be using our local tree. Cool. So then we're gonna say gdns.go. I'm just gonna add the log message here. And now why don't we actually just make this our compile command. Change the directory first. There we go. The no installer part has largely been due to nobody working on one and thinking the install scripts are fine. Things have changed a bit with things like Calamares. What's Calamares? I run Ubuntu on my workstations. I'm lazy. Yeah, that's fair. I can see the appeal in using a widely used system. The pros of Arch is still a rather simple package system and close to non-patching of upstream projects, which makes it for a simple distro. Yeah, it's pretty nice. Installers are pretty difficult to build for Linux in general, used to contribute to elementary OS. What did you find difficult about it specifically? Like, what are the pain points in writing an installer? For example, for distri, I've been thinking it should be sufficient to just copy all of the package images sequentially and then copy a small prepared system or bootstrap it actually. And then that should be able to complete very quickly in like a matter of seconds, and you could do much of it in the background after you ask the user for partitioning, and then there's only a couple of questions left before you can actually use the system. I think Fedora installs like that nowadays. Their installer, I think it asks you the bare minimum of questions, and then it does all of the heavy copying while you're still typing in answers, which I think is very good design. Calamares is the GUI, the graphical Qt installer project that Debian, Ubuntu, and Fedora uses now. Oh, really? Have Debian and Fedora merged their installer? That's news to me. Do you still use Debian? I use it on some systems. I have a couple of server systems where it makes sense to use it. I don't use it on my desktop right now, and I don't use it on any of my laptops right now. Just finished converting all my Linux boxes to Gen 2. Will never go back. Nice. Yeah, whatever makes you happy. Gen 2 certainly was nice back when I still used it. It is, but for an audience that wants to configure everything and the UI toolkit is not fixed. Huh. Okay. Doesn't have a choice on some of his machines. Who doesn't? And on which machines? Same project, then you fork and add plugins to it. So same framework, but distro-specific code there. Yeah, that makes sense. I just, has Debian really switched their default installer? I thought they were very attached to it, and I think I've seen emails about new versions of it very recently. So I haven't heard of it, but that doesn't mean much. Upgrading between versions is a pain too. Huh. Okay. Cool. So let's see. We're gonna go back. Oh yeah, cool. So the message that we added is on the device now. That's very nice. And we can see that the behavior is still the same. So it seems like HMQ just takes a little while to start up. I don't know why exactly. But it's good that it's reproducible. At least that gives us something to work with. I know Fedora uses it. Yeah, I think I've seen that Fedora has a nice installer project, but I just wasn't sure if any other distribution really uses it as well. All right, so there is a little program called run status, which to which I have added a while ago support to use the garlic package, which +1 for the name. So garlic allows you to listen to multicast connector messages, which is the only way that I know of to be notified by the Linux kernel for new processes starting and exiting. So it needs super user permission, of course, but we have that on gokrazy. So it should be possible to be notified about new programs, and then we can do something with the new process that appears. In this case, we would look for ports, probably repeatedly, actually. Actually, I'm not even sure if it's necessary to be notified in this case, because whenever we're being notified, if we do it with a high precision, like with this approach, then chances are very likely that we'll be checking programmatically for listening ports that are not even opened yet, because we get notified too early in the startup process. So we're going to need some frequency anyway, with which we're scanning the system, and we probably just want to do it periodically for now. So it might be very simple in terms of code changes. Debian switched in August 2019 for live medium portion. Oh, if you install from the live medium, but they still ship their traditional installer packages, or images rather. Doesn't systemd have a similar mechanism? A similar mechanism for what? Oh, for being notified of processes? I mean, possibly, but we're not using systemd, yeah, to detect new running services. Yeah, we're not using systemd on gokrazy though, right? If you remember, there's only 4 parts, and the gokrazy userland has its own very minimal init system. I think systemd does it by the virtue of using C groups. We don't mess with C groups in gokrazy for the time being. I mean, you could add it if you wanted to on top of what we're doing. Systemd syscalls could be used in gokrazy too, yeah, but I think it's entirely based on C groups. Whereas this interface that I found here, which has very little documentation as well, it's an AF netlink based, more recent interface, I think, is actually quite nice for if you want to do like a sidecar thing such as this. But yeah, as I mentioned, we might not actually necessarily need this. So remove this message here again, and then let's see where we stand. We have this function here, listen address, where that's where we do the query. And then, oh yeah, in our logic, we just call this once here. Then we iterate through all of these. Oh, and then the eg.wait statement here waits for all of the go-routines that we have running, which, let's see. Oh, that's just these calls here. So for every port that we have an http.serve call on the listener for the particular IP address on which we do the forwarding, and then has the proxy here, which is a new single host reverse proxy from the standard library's HTTP util package. I believe, yes, it's the net HTTP util. Cool. So yeah, I think all we want is oh yeah, so the thing that will now need to be added is keeping state of what's happening, so that we don't need to, or so that we don't accidentally try to recreate listeners and proxies for addresses that are not new. So now we need to keep track of what we know, which we already do to a certain extent here, apparently. So there's already a listeners. Cool. So then maybe we can really just run this in a loop. Yeah, maybe we're really just gonna say with like a minimum interval of 5 seconds in between. Cool. And then the eg.wait is effectively dead code, and we don't necessarily even need the error group anymore. We could just say we're just gonna do a go func. And we're just gonna if the serving fails, we're just gonna log.fatal, which is not good design in libraries, but in this case we're writing a program, and this is the error path that would have been taken anyway here in the logic function call. So if anything goes wrong, we can just log.fatal and we rely on gokrazy restarting the program, and then hopefully whatever error condition we ran into is going to be resolved, or it's going to be resolved over time, and we just crash loop, which is fine as well. So then we have the var eg, which is now unused. And maybe that's already good enough to fix this particular issue. Let's see. All right. It's kind of a shame that it takes so long for the Pi4 to restart. Let's switch to the capture here. I think the Pi3 was much quicker, and I think it's partly because of how the bootloader works on the Pi4 with all of the EEPROM updates and such. But yeah, I can only observe what's happening. Cool. Yeah, so these are happening pretty early, even though I don't even have a card inserted. It's kind of strange. Okay, it should be back up, so let's switch back. Cool. Okay, so now we have timestamps and timestamps.2. That's not great. Need to upgrade my Pi. Yeah. See, I don't. That's the whole point. So, okay, so clearly our deduplication hasn't worked, but what we can see, oh yeah, it's adding more and more, as we can see here. Oh, we should probably stop this then. But I wonder if HMQ will arrive here eventually. And if it has started up already, yeah, send it to this name. But it doesn't see it here apparently. Okay, we're gonna stop this just in case, you know, because I think all of these are now being created and I don't want it to run away. So let's see, what's not good here? Oh, I think this might be intentional behavior. Yeah, we deduplicate the name actually. But then what are we putting in here? The proxy address. Just based on the port. Oh, I think maybe we should only be using the name. If we're actually using it as well and creating the listener. Okay, let's give it a shot. We can speed up these iteration times a little bit, but for now, we're just going to keep it simple. I'm just going to update every time we make a change. We can have a ping here. Cool. And if you have any questions, feel free to interject. All right. So now we get nothing. How many times have you gone crazy? Enough. Which Go version are you using? I actually updated earlier today, so latest stable, which is 1.15.7. I tried the Go 1.16 beta version when it came out, and it actually had a bug that manifested itself as gokrazy no longer starting up because the init system's web interface had triggered a bug in the HTML template package. So I reported and they fixed it, and now I think it's working, but I should probably check the release candidate. Should buy some hardware to try these things. Been tempted to see what would need to be packaged to have Arch running as a decent router distro. Yeah, for sure. That's why I asked, yeah. Have you tried with the release candidate now? I'm on the beta version right now. Apple Silicon support. What was the bug? Let's see. There we go. So I was evaluating a template, and the template was evaluating a function, and then for some reason, in this mutex unlock code path here, there was a panic. And then let's see. This was the change that actually fixed it. It says attach functions to namespace. So I think it was because of the way that I load multiple templates from multiple files, and then how it wires them up. There was like a subtle thing that they got wrong. But then, yeah, it required a couple of lines. Well, quite a number of lines actually to be changed, to be fixed. Yeah, if you're curious, this is issue 43295. All right. Let's see. So this no longer lists anything, which is not exactly what we were going for. So let's see. Where do we actually? We make it here. But I think this is the only time where we write. Yeah. So this can't be true yet for the first iteration. So then why doesn't it print this line? It should. Okay, so time for a little more debugging it is. Okay, I don't have the CPU tool installed. Maybe I'm going to do that later, maybe not. So, oh, right, we can't find any new addresses because we didn't refresh the addresses within the loop, so that would explain that. Oh, and then if it starts too early, maybe it just started too early. We could verify by restarting this. Yep, okay. Cool, so that might actually explain it and fix all of our issues, and then let's review this change. Well, not the prettiest diff, but simple enough. Okay. Could you write a test for this? I could. We already have a test even for the listening addresses. Interesting. Oh, yeah, it does it in namespace. Very nice. Yeah, I think with regards to writing a test, let's first see. Oh, so this just is the listen addresses. I mean, this is almost only a control flow change, so it's almost going to be silly to write a test for it. You know, in terms of what additional coverage this gives us. Okay, so this time you can see that it came up. It's got HMQ, it got HMQ.2, which is both of the ports that we expect. 75B is the MQTT port, and 1F90 is the web interface port of the HMQ program. So now if we do timestamps.gokrazy/metrics, that works, and we should be able to do hmq2.gokrazy. Yeah, it gives us a 404, but that's to be expected. I don't know what the web interface actually expects, but we can see that the traffic has been forwarded, so that's good. That's what we were going for. Let me think real quick if it makes sense to add any sort of test here, really. Because like this whole part, you know, it's so few lines, and yeah, we need the manual test anyway, so yeah, I don't know. I'm not in the mood to write a test for this now, I think. Just gonna go with manual testing on this one. So let's push it to origin. Oh, I don't have that set up. Shouldn't be much harder than, wait a sec. Is there no, why didn't it show the .git directly? Anyway, maybe I should have refreshed. Okay, let's try again. Now via SSH instead of HTTPS. I know that there's like an instead of directive or something that can be configured, but some other time. Oh, and one thing that we forgot is to mention that the commit that we just added fixes this issue. So, oh, and we also didn't run the tests. Oops. Yeah, I think I need to run them with root permissions, yeah. But they pass locally, they pass remote. Okay, that's fine. So let's just mention this in this issue. All right, nice. That's done. Cool. So this was just a warm up because I wanted to fix this for quite a while. So now we have. And I thought it was nice to get people up to speed, so to say, with what it's like to work on gokrazy. So let's actually switch to our main repository, and then we have this larger issue that I wanted to take a look at and see if we can make any progress. Which capture cards do you use with the Raspberry Pi? So this is a Flint 4KP. You can just Google for that and you should get plenty of hits. The nice bit about it is that it works plug and play on Linux. So it has a USB-C connector here and a USB-A on the other end of this cable. Just plug it in, I plug in the Pi, and that's all I need to do. And then it shows up in OBS as I think it's a UVC USB camera device. All right, we have had Andy recently contributing some code. He is working on EVCC, which is an electric vehicle charge controller software, which he wants to build as an appliance on top of gokrazy. And he used a custom updater so that he could, implement his update policy and update the appliances out in the wild over the internet. And then he says that using the sequence of streaming to the root partition and saying switch with an intentionally broken root file system, for example, just the first 5 MB of the image, the device entered an endless reboot loop. And the expected behavior is that the invalid root would have been caught and the device should have switched back to other AB partition to make the device accessible again. So let me give you a little bit of background for people who are unfamiliar with this scheme. Okay, so in a gokrazy installation, there's 4 partitions. The first partition is 100 MB for boot. So this is where the Linux kernel and the Raspberry Pi firmware files are residing. It's a FAT16 file system because this is what the the Raspberry Pi bootloader expects, and the only file system type that it supports, as far as I understand, at least on the supported Pis that we currently have, so the Pi 3 and the Pi 4. Then we have 2 partitions, partition number 2 and partition number 3, that are 500 MB each. They are used as the root partition in an AB partitioning scheme. So we have one of them that's active, and while, for example, root 2 is active, updates are written to root 3, and then when the system restarts, it will switch over to root 3, and then updates are written to root 2. So both of them are identical in purpose, but only one of them will be active at any time, and the other one is used as the destination for updates. The file system is a squashfs read-only image, and then we have a 4th partition which you can create for spanning the entire rest of the device. So in my case, it's a ridiculously large USB drive with 128 MB. In many other cases, I have SD cards that fit like 4 GB or 8, 16, 32, whatever is the most common one that you can get in the electronics store around the corner, for example. Whatever you have should be fine, typically, unless you have very large application storage needs. And the 4th file system is used for permanent data, so you can format it as an ext4 or a FAT file system or anything else that the Linux kernel understands. Cool. So we have 2 of these partitions. So we have one of them is active, the other one isn't. However, the switch part, so here in the update procedure, there's the target.switch call, which switches from the active partition to the formerly non-active partition. That is kind of permanent. So if the destination partition doesn't work, then it will just not come up. And it will not automatically recover. And it would be cool if it could sort of do a test boot into the updated root partition. And then if that succeeds, it would switch. But it wouldn't switch before. It would only mark the next boot process as, hey, this should go into the test. So this would improve the reliability of the updating scheme, which would be nice. Okay, and then I commented that moin. The expected behavior is what this other comment here describes, where we had discussed auto-updating from within gokrazy, where somebody else, Carl, suggests, would it be possible to, first of all, download the kernel to a new location? Actually, the kernel is, so the kernel is going to be a special case because it actually resides in the boot partition, but there's like sort of 2 sub problems here that we can solve. So we could make the root tested, and then as an additional step, also the kernel. Download the kernel, or in our case, the root partition, to a new location without activating it. So that's the status quo for the root file system already. Then set up a watchdog event to reset the Pi in a few minutes, and kexec the new kernel. On successful DHCP or some other criteria, disable the watchdog and flip the bytes to point to the new partition. The watchdog is neat, but it would be nice even without that. Yeah, so what the watchdog gives you is automated recovery. Without the watchdog, you would need to observe that there's a failure, remove power, and then power it up again, and then at least it would automatically recover because it was only test booted into the new environment and it didn't permanently switch into the new environment yet. At least, depending on whether you're talking about the kernel or not, because for the kernel, we need to do some additional work. Okay, yeah, so I mentioned that this can work for the root file system, but not for the kernel. I later realized that, even though the boot partition is the same partition, that doesn't mean that we can't just store a new kernel version in a new file name that is otherwise unused. So we could still totally do this, but it requires one extra step here. And then the rest is update related. So let's go back to this issue. There's some confusion around what's happening currently. As I explained, the root file system uses AB partitioning, but has no way to test boot into a new partition. That's where we stand. Currently, the partitioning only helps with transferring updates. So overriding the non-active partition doesn't harm the active partition. So you can interrupt an update at any time, and it's going to be safe. But what you can't do is recover from having, for example, an intentionally broken, or during development you might break it not so intentionally, but still, once you update it to a broken image, it would not automatically recover. And it would be nice if it could, and if it automatically would. Somebody's asking, are you doing things with Go for i3? I am, to a certain extent. The most recent one that I've been working on is translations of our documentation, where we've been looking for how to structure a workflow where people can contribute translations, because we can't translate into so many languages. So for many of the languages, we need to rely on contributions anyway. But translations, like translating an entire whole document with the many pages that they sometimes have, can be a lot of work. So it would be cool if partial translations would be possible. And for updating existing documents, it is a must that partial translations should be possible. Then the documents also change. So there needs to be a system to mark them as out of date, ideally also on the per section level that we target with the partial translations. And ideally, we would like to use local tooling instead of additional hosted services. In addition, we couldn't even find a service that would do what we want here. Then the proposal that I have for how to address it is that currently we're using ASCII-doc, which is similar in purpose to Markdown, but it goes a little bit further. It has a little bit more directives that translate into HTML output. We don't necessarily need all of that power for the little bit of documentation that we have, or the little bit of structure that we have in our documentation. So we'll be fine with Markdown. But what we can do in Markdown that we cannot easily do in ASCII-doc is we can add these custom attributes onto our individual headings. So for each of the sections, we can not only give it an ID, but we can also give it a key value here, introduced and translated. Introduced is for versioning the documentation so that we can have a little marker. Thanks for reporting the spam. So we can have a little marker here for when a certain thing was introduced, and translated gives the translation status. So we can then use this and relatively easily write a custom Markdown renderer. And I have a sketch for this, and this is implemented in Go. It's currently in a separate repository, but I want to move it back to... if you want to mod me, I can deal with the spam. Yeah, thanks. How do I do this? The TL8 render, that's a translation renderer. I'm not going to talk about it in much detail here right now, also because it's in very early stages and not yet fully merged. But you can see it's only roughly 250 lines of Go code to implement the additional rendering. So we have this little version node, additional AST nodes that, based on the header attributes, we parse out the class and translate it. Then we insert it into the AST, and then we have a render function for how to render this and turn it into HTML. So it's a very nice way of customizing your documentation system, which can be based on Markdown, on a very, very, to its core level, essentially. And it's very nice to do this in Go, also because there's very little dependencies here. There's only the Goldmark package that I'm building upon, and then the rename.io for doing safe file access. So I'm planning to merge this into the i3 repository so that it's developed and versioned with the rest of the documentation, but it's not there yet. But this would be one of the things that I'm doing in the i3 project with Go. We have a couple of other things, tooling, for example, the i3 bot here that you can see that's adding GitHub labels and such. That's also implemented in Go. So all sorts of, auxiliary tooling is nice to do in Go whenever we have the chance. Previously, we would have done it in Perl. Also, the test suite is in Perl, but Perl's sort of on the decline, and Go is what I work with mostly nowadays, so I prefer to do it there. Cool. All right, so let me take a quick look at whether I can figure out how to make people a moderator. It says roles manager. Should probably player, moderator, safe. Cool. You should have permission now. Thank you for helping. Got it. Cool. Oh, so just type /mod and then username. Thank you. Next time. Cool. So let me go back to my stream here. So okay, so what we want to do is implement the Testboot. So first of all, I think we're gonna have a look at what's actually happening. So we have the Pi here. Let me show the picture again. So we have the Pi here. We have the USB drive for easy moving it over to the host system onto this USB hub here, and then recovering it by just using the gokrazy packer and directing it to this device. So if we screw up an update, it's no big deal. We can just recover it manually. And then we have the capture card here, which is capturing the HDMI output of the Pi. So if it fails in early boot, we'll see what's happening there. So we're in a good position to work on this sort of low-level early boot stuff. And conceptually, let me actually show you. I think this is up to date. Yeah. We have an update.go file. And there's a couple of handlers here, and then there's the init. So and that's it. So 170 lines currently. So this is what implements the update process on the device side. So we have update, mbr, root, switch, boot, and boot only, and then we have reboot. Most of these are just update handlers. So there's the boot, root, and mbr are all update handlers, but they're targeting different devices or partitions on a device. So we have the root dev package here, which has, for example, a block device accessor, which is determining the device based on the part UUID command line in the kernel, on the part UUID parameter in the kernel command line. Because it used to be static. It used to be, I think it was dev mmc blk0 p and then the partition number. But nowadays we use part UUID so that it doesn't matter anymore if you put it on an SD card or a USB stick, such as what I'm doing here, which is pretty cool. So this requires a little bit more logic to programmatically work with, which is what we're doing here with the part UUID resolution. We need to do all of this from scratch, and we can't just use the symlinks that UDEV would provide us in def, disk, by ID, and by serial, etc., and by path. All of these we don't have because we don't have UDEF running on our system. In fact, let me log into a BusyBox shell so that you can actually get a little bit better understanding of what is running on the system if it hasn't really clicked yet. And I get that it's an unusual setup, so it takes some time. So you can see here, there's the PID1 is gokrazy/init. And then we have all of these other processes. Everything that is in /gokrazy/ is system level. So we have randomness, loading and saving. We have DHCP client, NTP client, that's that. And then anything that is in /user/ is user provided. So that's where our timestamps program lives, the gdns that we worked on earlier. Timestamps actually has two processes because it uses privilege separation so that the network exporting is safe, and even if you crash the network visible part, it doesn't affect the rest. So this is non-privileged. You can also see here that the UID is not 0, it's not root, it's the nobody user. But I think we don't have the necessary files for PS to resolve these numbers into names here. Then we have the HMQ, and break glass is what we just used to get this shell. So that's the entire process tree, and anything that is in these square brackets is a Linux kernel thread. So these are not processes in that sense. So if we go back to the web interface, what you see here is actually a complete list of processes, right? It might not seem as such from the beginning. Actually, the sub-processes are not listed here. So for example, the timestamps only shows up in this list once, even though it uses the privilege separation approach. So it's not a complete list, but you get what I mean, right? It shows you everything that's running on the system, and I think that's pretty neat. Cool. So let's go back here. Okay, I explained update MBR, update root. These are just update handlers. Let me show you what an update handler is. It accepts a hash algorithm. We used to use SHA-256, which the nice bit is that it's cryptographically secure, but I don't think it needs to be, also because we now have support for TLS. So what we can now do is just use CRC32, which obviously it won't give as much reliability and no cryptographic safety at all, but it's much faster. And this is one of the key pieces to allow us to reach the update rates that we currently do on faster block devices, such as the USB stick. And then we have the stream request to function, which really is just open file, stream the bytes, sync and close. So, very naive file writing. And that's all you need to, accept the new update right now. But yeah, we're going to extend some of these functions, so we'll see how complicated it ends up later. Cool. So then we have the switch handler. Switch is a little bit different. It calls switch root partition. This does an update file, and then it does this stuff. So it goes on a little bit here, but not for much longer. So let me walk you through it. We have a fat file system reader. In the fat file system, we figure out the extents of the file name. In this particular case, commandline.txt. Extents means the offset and length of the file identified by this path, so that we know where exactly on disk is actually stored at. And then we just seek the file handle that we have here with os.openFile. You can see we open it for read and write. So we seek it to the start, then we seek it to offset from the start. Then we read the length, so we read the entire file contents, and then we seek back to the offset again, and we write it back out, but we replace the root equals kernel parameter. So this is how the switching is done, right? So when it figures out, the current root equals, maybe it would show root equals in earlier versions, it would be BLK0P2, and then this code would replace it into root equals def MZBLK0P3, for example, and vice versa. Nowadays, it's all part UUID based, I think. So Oh yeah. And this is a little fun bit here. Because we override the file in place, and we don't, you know, if we make it shorter, which can happen when you switch, yeah, when you switch from part UID to something else, which normally you wouldn't, but depending on which version your tool has, your updater tool, it might happen. So this was one of the cases that I ran into while I was developing this. So I figured it might be good to fix it for other people as well, so that people don't need to pay attention to all of the versions that they're using, maybe even across multiple machines, just as an additional safety net. And what we do to address this is we just pad the command line at the end so that the file always, it remains in the same size if you change everything in place. So if it's just a 3 with a 2 and vice versa, then file size doesn't change. But if for some reason the kernel command line becomes shorter, then we just pad it at the end so that we can still overwrite the entire file from start to finish. And that's the most complicated handler I think that we currently have, which is the switch handler. The others just accept data. And then let's see, this says switch root partition. Oh yeah, so this is the boot only is a little bit special in that it, after it updates the boot partition with an update handler, it switches to the active partition, not to the formerly inactive partition. And it does this to retain the current pointer, so to say, to the current partition, because updating the boot partition contents might reset it, because that's where the command line file is stored. All right, and then we have /reboot. And this is really where another big piece of the puzzle comes in, because this is where we do a kexec reboot if we can. So with if we can, I mean, if the architecture allows for it. So you can see here that the reboot.go file has the reboot_amd64.go suffix. And I think we have, oh, we don't even have, oh, actually, yeah, see, we don't have this for ARM64, which is what we need for gokrazy. So actually, oh, so the non-suffixed one, yeah, see, this is where we use the build tag. The non-suffixed one just does a reboot, and the ARM64, the AMD64 one does a kexec reboot. And it would be neat if we could do the same with ARM64, because then we could just say we're gonna kexec into the new kernel, maybe even with a new command line. Yeah, we could give it a new command line, and that way we could test both a new kernel file and also a new command line without persisting anything to disk. And then, once we determine that everything came up correctly, we can persist the switch and complete it like that. So we would need to add like a pending file of some sort to indicate that an update is in progress and that a switch should be made. And then maybe we could have a look right now at whether kexec is possible on ARM64. I think it wasn't possible when I last looked, which is why this is gated for the architecture. Yeah, it's enosys on kernels without config kexec file load. So maybe we can take a look. I think we should have proc config.gc. Yeah. Let's see. Do we have gzip? Yeah. So gzip-d proc config.gc. I don't know if it would otherwise write to standard out, but yeah. Yep. Okay, so kexec file load is not enabled. Maybe we can actually Google for this and see. Oh yeah, so it looks like somebody contributed it maybe. There was a patch set at least. But I don't know if it was merged or not. Let's see if these give us any indication of the supported architectures. So we can see there's, oh yeah, ARM64, starting 5.0 up to 5.3, but I think that's just when this database was assembled. But this is kexec verify sig and not file load. Oh, but this entire database page is for verify sig, okay. But then, yeah, maybe we should just try it, see if that works. So let's see. I think I'll need to pull this repository because it might not be up to date. And then we're just going to try enabling it and see if that compiles. Yeah, it's going to take a little while to update this because it contains a lot of kernel images at this point. Probably truncate the repository at some point. Okay. Maybe we can actually navigate to the correct. Are the images stored as binary blobs in the repo? Yes. Let's see if it actually follows this pattern. No, it doesn't. That's unfortunate. Oh, kernel config.io. Interesting. Oh, it has the recent version at least, so that's good. Oh, and then we could do ARM64 config kexec file. But why does it? Maybe we should. Okay, so repository is complete. Okay, let's take a look. I think it's just in the config. Oh no, config is the other one. Oh yeah, we have the config addendum just in here as a literal. And I think, yeah, kexec is not in here. It should be, and I don't know if I have that. Yeah, I don't have that other kernel repository. But we can take a quick look here because I had already enabled it here. Yep. Okay, so it just seems to be that one additional config option. So close this again. Actually, let's go from the bottom. Cool. And I think the rebuild tool actually recompiles the build tool anyway. So now all we need is gokrazy rebuild kernel, I think. And then that should be it. And of course, in here, we should verify that the kernel repository is not currently replaced. So we'll need to tell the Go tool for the kernel also to look locally. Okay, so this is going to take a little while. Hopefully it compiles, and hopefully it results in a kernel that supports kexec. Is there something that we can do in the meantime? Oh yeah, we wanted to take a look at this, but it doesn't even show kexec load file in here. It's a bit strange. If anybody understands why, please let me know, or how I could look this up somewhere. I think in the kernel source tree itself, it might be possible, though. We go to GitHub. I think if we look for the kexec files, it should be accompanied by a makefile. Oh wait, actually, machine kexec. Yeah, sounds about right. I wonder if it's going to work on the Raspberry Pi though, but yeah, we're going to see. That should also make the updates significantly faster, by the way. So it might be nice to just enable this on its own without any of the other improvements that we want to make. Yeah, I guess at this point we no longer need to confirm anything in the make file, but it's still nice to just take a look and see if we could see anything that would help us. Yeah, we can see config kexec file. Oh, maybe this is what we should have put into kernel config.io. Yeah, kexec file, and then go to ARM64, and that's how we could have confirmed it. Cool. Yeah, this is gonna still take a little while. Always a good chance to clean up tabs. This we can close as well. Okay, let's write down our current plan. So we want to enable kexec for ARM64 for the Raspberry Pi. Faster updates and to easily boot. I mean, this is not just easily. I think this is required to do a temporary boot. There's no other way. So welcome side effect, faster updates to make possible a temporary boot into a new kernel and or root file system. Then the next step would be add a Testboot handler, or maybe all lowercase because it's a URL. Could be called instead of switch. So this would take care of the root partition bit. And for the kernel, we would need to... Oh, so yeah, the kernel is a little bit more difficult. So maybe we're going to postpone this, but we can think about it nevertheless. So it's more difficult because we don't actually update the boot file system in place. We can't just add a new kernel version to it. We would need to bundle both the old and the new kernel, and then still overwrite the boot partition completely. Or, well, I don't know. No, you probably can't store the kernel on the other partition. Okay, so I'm gonna add a maybe later here. I'm gonna say generate a boot partition of the old and new kernel. Pretty sure I'm going to postpone that particular bit for later because there's currently no concept of an old and a new kernel, and I'm going to need to think if there should be one at all, or if not, or if there's some other way to make this work. With the old and new kernel, and the old would be the current one, and the new one would be like this. Make the packer generate a boot partition with the old and new kernel. And then the test boot could also pick up on this and say, oh, yeah, when it's in update mode, it should prefer the canary kernel. Right. Oh yeah, and then we need a component to the system which completes the update by essentially calling switch, or by doing or calling switch locally. Depending on where we place the component, it might be nice to just call the function instead of going through the interface, because it's going to be more reliable to call the function directly. Okay, so this is the current plan. Let me know if I forgot to add something or if anything is unclear. But I'm going to comment on this now so that it's saved, and then we can update it in place. All right, in the meantime, the kernel build finished. So, but But it didn't result in any changes, it says. So that is suspicious and might mean that our config addendum didn't have any effect. Huh. Or maybe it did actually already have the code compiled in. But then we should also be able to just make the syscall. So maybe we should just update and risk it. We can always do the reboot part manually if we should break it. So I think we're gonna do the easiest route here and just copy this over. But I think it would be nicer if we had a way to reuse the same code for both of the build architectures, but we're gonna figure out how this would work afterwards together. So let's see, what's our compile command? This should be it. Oh, and then of course in here, see, this is, I think it should be like this, but this is where I'm uncertain. I think due to the fact that there's like a recent proposal about build tags, there should be a link handy to how they work. Because currently they're not great. Okay, so each line listed a set of ORed conditions. This line indicated the file should be built on Linux, should build on Linux for any architecture, or on Windows only for 386. Okay, so space separated is this or that. So that is how I've used it. So that should work then. Okay. Reboot redeclared. So it didn't work. Why though? Previous declaration at reboot.go7, yeah. Let's see, reboot ARM64, ARM64. Is there like a silly mistake that I'm not seeing? On same lines or different lines is and, yes. But I have it on the same line, so this should, oh, because now it needs to be different because they're negated. So it needs to be like this then, right? Yeah, see? So this is why there is this proposal, because it's confusing. All right. Jawohl, yes. Thanks for pointing it out. Okay. But at least it compiled now, so the code itself should be fine. Let's see what will happen if we trigger the reboot endpoint. Cool, it's back. So let's see. I think the update stuff, yeah. We're gonna need to authorize ourselves. I think should be in here. Without that, cool. Update /update/ features. That might be a good URL to start. Yeah, very good. Okay, so now we can just trigger a reboot handler /reboot. Oh, it's not even in the update thing. And then it expects a post request. So reboot post request. Okay, I'm gonna send this, and I'm also gonna switch to the capture. Okay, so this did something. Let's see when it comes back. Should have probably timed this and checked if it came back faster, but at least it didn't result in an error, which I think would have happened if it wasn't supported. Okay, so then I would just assume that kexec is enabled by default in the kernel, and we don't even need this addendum here. So maybe the enabling is just not necessary. Is there any way to check if we've booted up with kexec? Oh. It's an x86 only trick, unfortunately. That's probably not going to help us then. We can still try if this works. Nope. Nope. Not reliably. Yeah, but I mean, we don't need to reliably do it, right? We just need to do it once. Actually, let's go back to the code and see if reboot ARM64. Oh, right. So it does a kexec.file load, and then it does a reboot kexec, but there's no. Oh yeah, no, there's a fallback here. So what we're going to do now is remove the fallback, and then if it still comes back, we know that it must have been kexec because there can't be any other way now. And also, let's see how long it takes to come back. Don't know if the kernel does ASLR like OpenBSD does, but that would mitigate most techniques for checking if it was kexec. Depends on the technique, I suppose. I mean, ASLR seems orthogonal to me to storing, for example, a marker in memory for whether the system was kexec or not. So this is still about 30 seconds, so I'm not so sure if that actually worked. But why don't we do this and see if the device reboots or no. Aha. So let's check the capture. Kexec reboot failed, device or resource busy. Okay, so our fallback code works, which is great, but the kexec itself doesn't work. So why does it not work? Kexec device or resource busy. Let's see if this is a common problem. Oh, it can't part the secondary CPUs. Huh. That's unfortunate. Okay, no, this is not even related, so no solution to this one apparently. Okay, not a lot. I mean, we could try and see if the suggested workaround here with the number CPUs equals 1 actually works, just to verify that we are indeed talking about this problem. Let's see if this sticks. Oh, right. Now we need to manually power off and power back on. Okay, here we go. Okay, let's see. The flag was added. Set a glass of water on a desk next to a Raspberry Pi and your keyboard. Yes, I like to live dangerously, by which I mean hydrate myself. No, it's been a long time since I've last spilled anything on my desk, and it never destroyed any of my hardware ever. So I'm reckless like that. Okay, doke. So let's do another famous last words. Yeah, for sure. Looks like it's been cast aside as a won't fix, unfortunately. Huh. Spilled a full cup of coffee on a dust keyboard once. That was an awful day. Yeah. Oh man. Cool. Hey, look. This looks better. Wow. Did you see that? This was like 5 seconds instead of 30. Right? So that looks like KXX to me. Let's have a look at the capture while this happens. Yeah, this is what we expected to see. Very neat, very neat. But unfortunately, the change that we needed to make, right? The NR CPUs, that means that we only have one core. Is that it? Can we even see the cores here like that? I don't think we can. Guess the coffee did wake you up completely. Yeah, that's the most efficient way to consume coffee. Instead of drinking it, you spill it over your keyboard. Okay, so this is indeed what was happening. Then Dot Waffle was sending a link here saying github.com Raspberry Pi Linux issues 27. Wow, that's not a large issue number. KXX doesn't quite work. 2012. That does not look good. There are some issues with booting kernels using KXX. It doesn't work. That is a large issue. Okay, so power management code is probably blocking when it tries to come up. To get any console output. Okay, this is a long discussion. I'm not going to go through all of it, but let's see what's happening here. Closing as a won't fix. This means that although the issue is acknowledged, it is felt that no further action is likely. This may be down to a bad benefit versus cost analysis, or it may actually not be possible to fix. Been quite a few years. Oh, hidden items. Why are all of these commits mentioning this issue? I'm not sure if this is really the same issue. Oh, there's mention of NCPU. NRCPU, I think. It doesn't, my browser at least doesn't find it. Let's see if this is maybe in the hidden items. Nope. Manifestation is the same, but the issue is different. Yeah, could be. That's what I'm thinking. But maybe maybe we can find something else with just these particular search words. Okay, there seems to be max CPUs equals ones. Let's patch the kernel. Sure. I mean, if there's already code for it that just wasn't accepted, we could, in theory, patch the gokrazy kernel to carry this until an upstream resolution is found, if there ever will be one. Also depends on how big the patch actually is. Okay. It seems like this one blog post here really is the only source of information on this particular issue. So it links to this mailing list. This may or may not be relevant. Gonna take a look at that in a sec. Machine kexec prepare. PSCI implementation. This was in 2017. And then somebody posted a patch, but it was rejected. Okay. Let's see. So kexec tools purgatory. Let's see what this says. Oh, this is more recent, only a year ago. Okay, this is a very detailed walkthrough. It's because the Raspberry Pi doesn't support CPU hot plugging, you have to do kexec with only one CPU active. Yeah. Thanks for stopping by. Have a great weekend too. Okay, so Raspberry Pi CPU hot plug. No, just general CPU hot plug in the Raspberry Pi repository. That's not what we want. Yeah, I don't know if there's like a good tracking issue where we could voice support or demand for having this implemented in upstream Linux. Maybe just like past your search results. Like, aren't there other use cases for CPU hot plugging other than kexec? CPU hot plug is disabled on the Pi in general, which is mentioned here in this issue? It's not a software thing. It's to do with the proprietary firmware Pi uses. Oh, really? Offlining a CPU results in a crash. Never been tested, not supported. It's a power saving exercise, then you can limit the CPUs by the command line. Okay, that's what we were doing right now to test. But it's not. We want to retain full power, but also have kexec. Maybe that's just not possible. Right, kexec won't ever work until this is fixed. Would be happy to consider a pull request if someone adds support. So, but that must mean that it's in the Linux kernel code path, right? Because they don't accept pull requests for the firmware. There's no hardware support for suspend. All 4 cores are clocked off the same clock. Okay. As soon as the ARM is brought out of reset, all 4 cores start executing. 3 of the cores spin, waiting for a signal from the first core. And I suppose that's sort of the state into which we would want to place the cores for just before kexec. Once the first core has initialized enough, SMP boot secondary is called, which makes the other cores branch off to secondary startup. There is no way to really stop any cores. All you can do is wait for interrupt. But that happens anyway when CPU is low. Yeah. I guess we would need to get them into wait for interrupt. Okay, so that's kind of why they don't have it, I suppose. And then at some point, oh, what does this say? Right, they just remove the config options entirely. It's fair. Okay, that's sort of an unfortunate roadblock. I suppose that, you know, is there any other way to like temporarily reboot a command line with the Raspberry Pi bootloader maybe? Maybe we could check that, but if no, we should at least take some notes here. Exec only works with, is that the correct? Yeah, and our CPU is equals 1. By the way, actually, this command line looks a lot shorter than previously. You know, previously it had all of this stuff in it, which presumably the Raspberry Pi bootloader adds to it. So that would mean that if we do a if we do a kexec reboot, we don't have all of these bits of the command line because we supply the code in reboot arm64.go here that just reads command line.txt. So that would need to be fixed as well. Do you really need kexec though? Could you not just install some kind of shim init that reloads into the new environment and reuse the kernel? Then you only need to do the longer full reboot path to upgrade the kernel as well. Yeah, I mean for the other partition, for the other root file system, you could do kind of like a pivot root thing. But I'm not entirely sure if you would need to do it in an init.rd or not. Which we currently don't have an init.rd. And if could you do it in the init? You could presumably, yeah, maybe, but you would need to do it very early, I think. But I think first of all, we're gonna note down what we find here, and then we're gonna clean up, and then we're gonna continue. So kexec only works with limiting the number of CPUs to 1, and the link to the issue. This means cannot use kexec because 3 additional cores to evaluate in practice this feature. But it sounds like maybe, you know, it could presumably be patched somehow by somebody who has enough time and knowledge. Okay, so let's go back here, command.txt, revert this change, revert that change. No custom kernel needed after all. Sure. Oh, right. Close the wrong window, but that's fine. So this one we're gonna drop. Okay. Okay, no kexec for now. And let's also do another packer so that we're on a known version. Oh, it would actually, I think it might kexec still now. Maybe. But then it should be back by now. We'll see. I'll do another manual reboot after. Okay. Let me turn it off. Turn back on. Yeah, some kind of shim in it. I think this might be. So this, I think this is the second function. Oh, I don't have the packer source code. Crazy. Oops. Okay. Build init. Okay, so this is what func main looks like for PID1 for our init system. So we have gokrazy.boot, which is being called, and then we supervise. So gokrazy.boot is here. All right, and this is where we do the mount fs, but the root file system is already mounted at that point because our PID1 is starting from that root file system. But yeah, so if we could read like a flag file that indicated that an update was in progress, I think there's like a, oh, we should also clean up some tabs. Actually, this one we might want to retain. Because it was a good resource, just in case we need to go back to it later. Okay, so I think there was a good description of what this process looks like in practice. There was like a short implementation of it, I think, in some sort of blog post. Maybe it's referenced here. Oh, I think the BusyBox codebase contained a good implementation of it. Let's see. These two man pages. No, they're just high level. High level. Okay, let's see. BusyBox root. No, wait, this is not any sort of official documentation. Is BusyBox on GitHub? There's a mirror. Pivot, let's see. Was it this one maybe? Oh yeah, right. Okay, so, but this is for the initial init.rd, but maybe we can kind of deduce how our switching would work based on this, or you know, similarly to this. Essentially, it's doing mount --move. and you need to do it as like a series of syscalls, and you can't do it in a shell script. But probably we're going to be in a position to do it in Go. And then it's doing change root. So cd mount change root essentially is the sequence. Okay, so let's see what they do here. They have the exchange root call. And then they have the mount call with the ms move. Actually, should be able to find something for this. Maybe I've even done one of these myself at some point. It wouldn't surprise me. Maybe in let's see. Yeah, in minute.rd. Yeah, this is the sequence that we need. So I suppose we could try that. However, okay, so then the next question though is what sort of flag would we store and where would we store it? Because we can't write to the root partition. We would need to write it to the permanent partition, and then the permanent partition would need to exist for this update mechanism to work. Or we would actually see, this is the problem though, right? Like you need a flag that is permanent enough to be set, or you just do the logic of it, right? Like, yeah, this is how it would need to work, right? Let's go back here and say let's guard it. We need to add a flag that signals to gokrazy's next boot that an update should be attempted. Then the updater resets the flag. Next boot will result in the old version. And then updater execute maybe. No, that won't work because we're talking about multiple boot processes, right? Multiple boots. How do you call that? Booting the system multiple times. The updater change roots into the well, let's say inactive root partition. If that works, the inactive root partition is marked active for the next boot. So there will be next boot will pick up new version. So we need to have a flag that has multiple states, right? We would have try inactive maybe. And we would need to have a trying inactive, which would no longer trigger the same code path on the next boot, but it would need to be switched to actually it would need to be removed. It's marked active and the flag is removed. Is the recipe MBR or GPT? It is MBR. Yep. Okay. So that's the revised plan. Let's see if we can make a little bit of progress on this and how far we come. So we want to add a flag that signals to the next boot that an update should be attempted, and this would be called something like try inactive. And I think we want to add it to the, I think we want to just store it in the kernel command line actually. So this would be something like gokrazy dot try boot inactive equals 1. And then do we actually really need to, oh yeah, we need to make it inactive, right? So, but could we also already just remove it here? Probably, right? Oh, no, we still want to know if we should do the marking, so that's why we need to carry it forward. But it needs to be switch on boot. And then that should be removed as well. So, okay, so that's what it would be, right? We have this, we say remove gokrazy try boot inactive, but add switch on boot. And then this one here should say remove gokrazy switch on boot. But only that works. Okay. Cool. Yeah, so that's basically it. So we need a new Testboot handler, which just adds this flag instead of doing a switch. So why don't we go back here? We're going to update.go. We have the switch root partition here. That's a function that we're going to update, I think. And instead of having the switch here, I'm going to say Testboot. And it's going to be not a non-concurrent switch handler, but non-concurrent Testboot handler. It's going to copy this. Going to worry about refactoring later. Non-concurrent Testboot handler. Oh, and we can even just give it the inactive partition number that we want to boot from. Though we could also deduce it from the code, so it doesn't really matter. Instead of switch root partition, oh, so this has one issue, which is that it'll need to extend the command line. So we'll need to make the file bigger to begin with. So this time we'll probably need to do padding that we then remove. So we'll probably need to do yeah, right command line. That's what we were looking for. Okay, so and I think we just want to unconditionally extend it with like, I don't know, let's say 64 spaces. That should be enough for all of the parameters that we want to replace into it. Right. Like this, right? And then the pad should just be 64. Enough for flags used during update. Actually, have the kernel command line with enough white space that can be used in place file overrides to add additional command line flags for the gokrazy update process. Just so that we have a little bit of breadcrumbs here to follow for future readers of this code. Number of kernel parameters is not limited, but the length of the complete command line is limited to a fixed number of characters. This limit depends on the architecture and is between 256 and 4K. It's defined in the file include asm setup.h as command line size. Nice. Is it also a parameter in proc config? Actually, command line. Oh, wow. It doesn't have this syntax. No, it's not queryable. So, you know, even if we assume, well, actually, let's take a look at how long this really is. We do have word count 440. Okay. But that must mean that we are way beyond the 256 already, right? We could probably go to the Linux repository and take a look. Command line size. Can we find ARM64 in here? There's probably like a yeah. I can never remember which atoms correspond to the file name. File with this file name. ARM? Maybe? No. See, this never works. Wasn't there also livegrep.com where you can do command line size? Path ARM64. There we go. 2K. You say it was 256, now it's 1024. Yeah, but look, like in this file it's even 2K, right? So maybe they've bumped it again. Okay, but you know, either way, whether it's 1K or 2K, it's going to be plenty for what we need to store, because we only use 440 right now with all of the stuff that the Raspberry Pi puts in. And we add a padding of 64, so that would even be under 512. So we're going to have plenty of space. But thank you for the pointer. So this is that change. Let's install the packer again, and then we're going to do a new update here. Oh, yeah, maybe I should have left it open. And then we're going to do one update. Okay, so let's go back to update.go. This is now the function where we, so I think we just want to refactor this switch root partition function to like allow for an arbitrary modification of the file contents. Currently, this is what we're doing. So the rep, yeah, I think that's what we want to do here. Modify command line. And we're just going to say you need to specify a func from byte to byte, byte slice to byte slice. Can return an error, and then we're just going to re-implement this one on top of the other. By saying return func the input is going to be called B, and we just return rep, and that's it. Oh, and we have the length here. Oh, length is just the length of the byte slice. So That should be identical to len of b, I believe. Mismatch type int and int64. Oh yeah, I mean, cool in that case. Then that makes everything ints, and that's actually nicer type system-wise. Okay, and then we have the rep, which is now a function, so this will need to be rep b. And that's what we return and write and update in place. Cool. This could be it already. So then instead of switch root partition, what we're going to do is we're going to add a new function. Enable Testboot. New root partition is unnecessary. Enabling Testboot of new root partition. Person Q failed. Yep, that seems all right. And then enable Testboot. And the modification of the command line that we want is, we're just going to say return append to be this string from our plan, and that's that. Yep, okay, so this should be what the new handler does. This is a much nicer diff now. Okay, so enable testboot when we do update / testboot, and then we should come up with the new command line. We should be able to test this easily, actually. So as soon as we deploy this, afterwards, once we do another reboot after enabling testboot, it should come up with the new kernel command line, and we should be able to see it in break glass and just, you know, cut proc command line. We don't yet pick it up in any of our update code, but you know, that'll be the next step. First step is to verify that this is working. We always need two updates here. One of them to get the new updater code in place, and then the other one to actually run the new updater code and trigger the testboot endpoint. So update testboot. Well, actually, proc command line. Okay, so we don't see the flag in here right now, so that's good. And we note that we are on partition 3 currently. So just going to do the testboot here. And then I'm going to say reboot. And let's see what comes back up. Not that familiar with Go yet. When does one use defer, and when just write the statement to the end of scope? Well, you would use defer so that if you have multiple return paths from the same scope, you don't need to add your code to all of them, right? It's just a way for you to say, oh, in all of the upcoming ways that one could exit this scope, run this code, right? So you can't forget it. So for typical cleanup stuff is when you would use it. Okay, so it came back here. Let's see. Doesn't look like it was added here. That's disappointing. Why not? I mean, we're still in the active partition. Let's see. The testboot one shouldn't do anything, and I think it didn't, right? Yeah, we did the testboot and then we did the reboot after. I suppose we could in the testboot. Oh, actually, concurrent testboot handler doesn't. Oh, it used the new root partition for the error message. That's fine. I think the file system, the boot file system, is not typically mounted, so, and I think we don't even, we don't even have the directory for it. But we could do def sta1 on temp boot and just look at temp boot command line.txt. That's where we are right now. So if we do unmount temp boot, and then we hit the testboot endpoint, mount it again, cat it again, it seems unchanged. Let's switch to the capture. There's no obvious error messages in here other than the obvious error messages that the device prints out itself. Is there like an obvious problem that we have somewhere? We're writing out. Oh, we should probably do the padding not in here, but move that in here. But that's not the problem that we're having. I wonder if we can still successfully switch or no. Yeah, the switch still works. So let's switch back. Does it work like this? I don't even know. No. Switch is one way. Okay. Fair enough. Then why doesn't this one work? So it must be related somehow to this, I suppose. But I don't see a mistake with it. Maybe we should add a trailing new line, just like the code here does. Oh, also, oh, is it actually? I have a suspicion. Let's see. Okay, no. So I think the problem with our previous code is that or the problem with our current code is, yeah, trailing null. Well, not quite, but our new line handling is not correct yet. So I think instead of, appending to the kernel command line would need to be like so. So we would need to replace the new line with I think that's how we should structure it. Replace the existing new line with, actually, and white space needs to be here with our appended command line. Okay, and then while we're here, actually, let's rename the one that we need less often. This one here, just be rep. Okay, so now the padding is done here for both of these, and then that one can be a little simpler. It just replaces bits and pieces. Okay. let's see. Let's reboot. Okay, so you're a fresh grad, just got my first job. How do you manage understanding how everything works / being productive and building on top of things? Can you let me know, like, how large is the company you're working in? Is it like, less than 10 people, less than 50 people, less than 500, less than 5,000? Because the size of the code base is typically related to how many people work at the company. And this answer is very different for different sizes of code bases, I think. Okay, should be back. Spent 10 minutes explaining Linux file permissions to my granddad, only to realize the SD card was locked with a physical switch. Yep, been there, done that. Ran into the physical switch. Okay, so this is now booting from the second one to which we switched, so that's good. I think it should have picked up our code change too, so why don't we do the mounting here again. 250 people working at the company. Yeah. So at that size, you'll have different developer teams who have different responsibilities. Which team are you working in? Are you working in sort of a horizontal infrastructure team where you need to really dive into many, many different parts of the code base? Or are you working in a team where you're mostly working within sort of your subject area's code base and you don't necessarily need to know so much about the rest? Okay, so this is where we stand. Web API services in Go. Okay. So then I think there's you can obviously learn how web services can be structured and written in Go from the internet, right? There's like a lot of tutorials, videos probably, maybe even books at this point. But then the question is, how does your team do it, right? So it might be that you have like a central middleware or that you have already established structures. I think it would pay off to just talk to your team about it, ask if they could do a code walkthrough with you, or you could, ask questions about, hypothetically, if you can always ask your colleagues and questions such as, I'm about to modify this and that, or I have no idea where I would change this and that. Can you give me a couple of short pointers? Where they can just send you a link to the coding question and say, yeah, start reading here and then dive deeper, right? And then you can just click through. I'm not sure if you like which tooling you work with, but if you haven't seen it, I can just go over any identifier and tell my editor to dive into the definition. I think that would be one of the first things that I would enable in the code base you're working in, so that you can quickly use your tool to like jump through the source code and that way figure out the control flow. Yeah, those are just a couple of tips. There's probably more. Is that helpful at all, or are you looking for something different? So let's switch back here. Say we're gonna do the Testboot mount at. Yeah, look, now it's there. Okay, not entirely sure what happened there previously, but now it's doing it correctly with regards to the white space and the new line and everything seems to work fine. It's this Swiss MD layer stream. Are we so similar? Okay, unmount. So this looks good. Cool. Do both like networks? True. Who doesn't? Okay, so now that we have the kernel parameter, let's actually trigger a reboot. See if the kernel parameter makes it into the command line. Just need NetLayer to drink the i3 tea. Totally. You also like networks. Are you MedLayer too? Aren't we all a little bit MedLayer? That's pretty helpful. Guess I'm just anxious. Yeah. I can empathize, but there's only one thing that's worse than people asking a lot of silly questions, and that's the people who don't ask these silly questions, because there's really no way around them. And just ask them first. I think it's much more of a strength of character to be able to admit that you don't know something and that you would appreciate a pointer and where you're stuck, because then people can at least work with you and give you the support that you need. Yeah, try to get over that bit of anxiousness. It pays off. Cool. So you should always ask questions and know that it's okay to make mistakes. Yes, absolutely. So, oh yeah, look at this. So proc command line now contains the gokrazy.tryboot inactive parameter. So that's good. So now we can smuggle something from the start of the update process to the subsequent boot. And now actually let's go into gokrazy.go into the boot. Okay, so we're gonna think later about how we want the watchdog to be involved in this, if at all. But first of all, we should look for gokrazy.tryboot inactive. And if found, switch to the inactive root partition instead. We already have this kind of, actually, you know what we're gonna do? We're gonna add more boxes. Okay, so now we can have the satisfaction of saying we tick this one. Very nice. Okay, so the next boot will result in the old version if this flag is found. Actually, we didn't actually finish this one. We finished that one, but that's sort of, see, I structured this wrong. Anyway. If found update command line such that sometimes miss how easy it is to set up a new web app with Django, but I love the freedom of Go. Yeah, always the question for, do you want the opinionated environment or no? For different things, there's different answers here. If found update command line such that gokrazy.switch on boot is one. So this time we're going to do a replacement, I think. And I think what we're just going to do... Just going to add all of our stuff into a new function here, so that it's nicely separated. And then we're going to say read file proc. Oh, actually, the proc file system is only mounted here. So the earliest that we can actually run this code is here. I'm going to make a note here to think about whether the watchdog needs different setup during the update process. Okay. Okay, so now we can read proc. Specifically, I'm helping to rewrite one of our payment APIs from REST to gRPC. Yeah, that is definitely a question where you should take a good look at the gRPC interfaces that are already there. Or are you going out to define a gRPC interface? In either case, you're going to need to talk to lots of your colleagues about this, everybody involved, to make sure that everybody also understands the new structure, etc. So yeah, for this particular task, there is really no way around communicating. All right, so if there's an error, we're going to print it, and we're going to return, because then we can't switch to inactive if we can't read the command line. And check if strings.contains command line, not yet a string, or we're going to make it one. If it contains gokrazy.tryboot inactive. Actually, if it doesn't contain it, we're done. But if it does contain it, cool. Stream recommendations, check out the chat for that. Switching to inactive partition. Okay, we should probably also figure out which one that is. We can copy the code for that right after. But first, we need to update the command line. So that's here. Maybe we could just do this. And then what we're going to say here is, well, right, this time we don't need to care about the line endings. IOUtil.read file, retro go stream. Yes, the IOUtil package has been deprecated very recently, I want to add. So I'm still using it here. Okay, so this needs to be replaced with what did we say? Go crazy, switch and boot equals 1. Right. Okay, and then switch to the inactive root partition instead. So for this, we would... Oh, we need to also do the mounts? No, it will do the mounts later if we do a reexec. So I think we really just need a mount point for the other root file system. And then we kind of need that bit. So let's see. Switch root. Trans an error. Okay. Okay. Mount the inactive root partition on a temporary mount point. So our mount point would really need to live in /temp, which we have mounted before because the mount function is called before. So yeah. Well, make it short. Temp mount file path.join. Oh, it's temp here. Mount, why not? This early in the boot, that is unused. So create it. Probably actually switch to inactive root. Just gonna move all of that into this function as well. Switch to inactive root, and then just return this error here. Right, the root file system, we don't actually explicitly mount it anywhere yet, so we can't just copy that. But why don't we have a look at the others here? Because it should be very similar to the permanent file system. Oh yeah. Okay. And the device here is rootdev dot inactive root partition. But that returns an int. I'll have a look in a sec. So that will need to be mounted onto a temp mount. And the fs type, I think is going to be squash fs. I don't know for sure. I mean, I know for sure that it's going to be a squashable image, but I don't know if that is the correct spelling, etc. of the type. I suppose we're going to find out. Let's change there. Okay, so it's the only occurrence. Good. Now, let's see if we don't already have a helper. Oh yeah, the partition function is what we need to. Partition, and then give it a partition number, and it gives us the device path. Good. So let's see where we stand. We have to switch on boot, and then we should end up in the old. Yeah. Okay. Let's see if this builds. Okay. Good first sign. Okay. So then, this is where we stand. Okay. And the test boot. Yeah, I think we'll actually need to. We'll actually need to touch the updater now. And I think just instead of doing a switch, we would want to do a test boot. I think that's it. And then we just need a flag for it. Gonna add this later. Right. The updater. It lives in its own repository. So just gonna set that up real quick. Cool. Place. Okay. Okay, now it's writable. Testboot. Update testboot. Yep, that should be it. Amazing how long it takes to get something simple working sometimes. Just spend a couple hours working on like 2 data structures and auto flags. Yeah, for sure. Okay, test boot, that's good. This should also be good now. Yep. Okay. Go install. And now, if we did the old line here and just added dash testboot, let's see what happens. Switch to the capture, see what we see there. But it's probably just going to be a regular boot, I suppose. Oh no, look. Open proc command line, no such file directory. Huh. Oh yeah, so the so this should be the failed boot attempt, and then now it should revert, right? It should go back because we have reboot on oops is enabled, and hopefully it should have changed the flag file, and by flag file I mean the kernel command line, to no longer contain the instruction to start the inactive one. So yeah, that actually looks good in terms of recovering, right? Yeah, there it is. Oh, very nice. So we did our first failed boot. Isn't that a nice milestone? Okay, so let's see. Nice work, thank you. So we did this, it changed roots into the inactive partition, and then this is where we are, right? If that would work, we would need to update, but it doesn't even work right now. Because file systems. I want to spend all of my day on serializing an NRHA, questioned all of my life, lowest self-esteem ever. Yep, sometimes it just is like that. Sometimes it can help to, clear your mind, take a shower, take a walk, have a good night's sleep, come back the other day. Sometimes it makes this really much easier. Or try to switch your medium, switch from computer to paper, from paper to whiteboard, from whiteboard to talking to your plush animal. Yeah, stepping away is often the best option, yeah. Context switching can really help, when you intentionally induce it. Are you currently working from home? I am, yeah. I think I've exhausted my coding capacity for the day. Yeah. Speaking of, we are at 2:30 right now, so I'm gonna see if it's possible to figure out the file system issues that we have right now. But I'm probably not going to spend much more than the next half an hour, so we'll see how far we come. But we've already reached a nice milestone here, I think. At least laying the foundation work for making this possible. Okay, so what we saw on the stream is that what we saw on the capture card is that it couldn't find /proc/command line. So I think if we go back to the, not the updater, but just the update.go. No, wait. Sorry, gokrazy.go. Switch to inactive root. So it does the change root, change dir, and then it executes /init. So far, so good, I think. No, wait, /init is actually wrong. How can it even exec anything? Oh, maybe the exec fails, and then it tries to continue, but now it's in the change dir. That would be it. So maybe that's all we need to fix. So the init parameter on gokrazy needs to be /gokrazy/init because of our split of files. So if you remember, I mentioned that everything system provided is in /gokrazy, everything user provided is in /user. So init is system provided, so it's part of /gokrazy/init. So maybe that's all we need. Okay, let's do an update. Oh wait, it's doing a Testboot update. Is that good or bad? It might be too early for one. I think I might need to do a regular update first before I can do a Testboot update, but let's see what it does. Okay, no, still an error message. Let me try a regular update first. Let me go back to here. change our compile command again to not contain the testboot flag. It's kind of annoying that it always takes like half a minute for these updates to happen. I mentioned earlier how on the Pi 3 it was much faster. On the Pi 4 it became a lot slower. And I think it's because of the EEPROM updates as an additional step, or maybe the boot just takes longer. But it's all in the firmware part. We enabled the kexec earlier. We had to restrict to 1 core, but once you do that in kexec, it only took 5 seconds. So we now know that of the 30 seconds it takes here, only 5 of them are kernel, and the other 25 are bootloader. It's way too long. Okay, so that's the non-test boot. Let's try a -test boot, and let's see what is happening here then. Okay, so it says switching to inactive root. Wait, what happened here? Did it reboot again? It looks like. Why? Didn't even see it. Or was it maybe watchdog triggered? Not sure. Any expectation on Pi 5, particularly after what Apple achieved with ARM? Yeah, certainly impressive. I don't think that the other... So I think the way I understood it is that the Apple ARM designs can be so much better because they are not necessarily compatible with what the others need to do, right? So for example, if Apple realizes that on a desktop you need to have a good GPU that has good interfaces with other parts of the system, but you don't need, let's say, like a PS2 legacy controller, right? Then they can say, oh yeah, we're just going to budget this and that much of our silicon and design to a GPU and these interfaces, etc. And no other vendor necessarily has them. So on the Pi 5, however, because Raspberry Pi doesn't own the software implementation, it's just a regular Linux, they would need to do all of these changes. And I'm not sure if they think that there's a good reason to do so, contrary to the market that Apple wants to satisfy, right? Like you've seen earlier how even the turning off the other CPUs to enable kexec is not in the priorities. So who knows what the priorities are? Definitely the Pi Foundation has a lot smaller pockets than Apple has. So I wouldn't hold my breath on the Pi 5 shipping anything like that. However, we've seen with the Pico Pi, the microcontroller that they came up with, that it's certainly possible for them to come up with custom ARM-based designs, but it's a lot smaller ARM-based designs, Cortex M0, that they changed into microcontroller. So I'm not sure if they want to go into custom cores, but they seem to be making some progress. I definitely don't think it's going to be with the Pi 5 or anything. Maybe a couple of revisions down the line. Maybe if other CPU vendors follow suit to what Apple did in terms of re-architecting, maybe that changes the landscape a little bit. But currently it looks like Apple is the outlier and the others aren't necessarily expected to follow. But hey, who knows? Certainly interesting to follow. Okay, so not entirely sure what happened in the last boot. It was pretty quick. Maybe what we should do is try the serial interface. I'm thinking if I still want to regarding taking a break, it's weird how the brain works sometimes. I get exhausted on a problem for an hour and then come back the next day and figure out instantly. Yep. This diffuse mode learning is something I'll actively do. Not worth wrecking your mind over something. If you know, break will help. Absolutely. And then there's a link. Nice. Thanks for the link. Yeah, I've observed this so many times. Sometimes you're just stuck, and no matter how many hours you're going to sink into the problem, it's not going to get any better. So taking a break is much more effective. Okay, so Yeah, I think we almost have to switch to like the serial console. So actually, let me do a quick blank screen. Okay, so I just connected another USB to serial adapter. Let me see, it should be TTY USB 1. TTY USB 1, yep. And then we'll need to remove the serial console equals disabled flag, which will also mean that the console will no longer go onto the HDMI output. So the capture card setup will be not as useful anymore, but hopefully we should see the serial messages here. Oh yeah, there we go. Nice. Because this is now easily loggable, so we can actually see the messages in full and don't need to hurry up with reading what's on the screen. And now we can try and do the Testboot one again, after enabling logging, of course. So let me first check that there's no existing log. We're going to do screenlog.0. And whenever we actually enable or disable it, actually writes it out, so you can see it's buffered. And then we're going to say is dash testboot, and now let's capture what is happening here. Okay, so it says switching to inactive root. Oh, is that related maybe? You know, the device or resource busy on the watchdog, and then if there's not going to be any messages and it just reboots, then I think it's probably the watchdog kicking in maybe. I think at this point it actually did reboot earlier, right? So it looks like it's kind of working now. Suspicious. Let's take a look here. It's also saying STA3 can't mount would change RO state. And then in 196 it says device or resource busy. Oh, switch to inactive root. It says device or resource busy. That's not good. So maybe it can't mount it after all. Let's take a look at what's mounted. So I think it hasn't actually switched over yet, right? If it fails in the mounting, but we don't know exactly where it's failing. So we should probably add all of our errors nicely here so that we can track this down. Change dir. This is a change dir as well. And then this one we need to change. Turn nil here. And I think I'm just gonna update this in the background while we can possibly think if there's anything else that we might be able to figure out already. So switching to inactive root. We would change the arrow state. Is that maybe a hint that we're trying to mount something writable, or we should be mounting it read-only? Like maybe in the syscall.mount we need to add a read-only flag. Syscall. Let's see. There's ms move. There's ms read-only. Maybe we would need this. Read-only. And then of course we would need another update for this. And the update would need to be of the base system, not of the target. So let's just do another iteration. Okay, cool. Now that it's updated, let's try the Testboot. Enable the logging, of course. It's going to append to the same file. It would be nicer if we could start a separate file. I don't know if there's an option on the screen to do that, but it's just something to keep in mind. If you don't mind, how is the testing setup for gokrazy? We have... Oh, wow. Oh, wow. Sorry. I'm interrupted because I'm amused. What's happening here? Is it like an infinite loop now? Switching to inactive root partition. And then the gokrazy build timestamp, that's of the new thing. Oh. Yeah, I think I know why. How do you upload the firmware, etc.? Oh, do you mean the setup that I'm using right now for the development? Or do you mean like the continuous integration that we have? Actually, let me turn this off and turn it back on. It should be, it should recover itself now automatically, I think. If the problem is what I'm thinking it is. Because we're always checking proc command line, but after we change the command line on disk, proc command line isn't automatically updated. So we should work with the command line from disk. Development setup. Yeah, take a look. So this is the device that I'm working on. Previously, I had connected it to his capture card. I mean, it still is connected to the capture card, but we just don't see a lot on the output anymore because all of the log lines are going to this USB to serial interface now, which I have just connected to my USB hub, and the other end here to the GPIO. So once you open the case, the GPIO line has the serial port. And then I have the power switch here where I can just turn off and on the device with a single button, or a single switch rather. And then how do you upload the firmware, etc.? Well, that's what you see here on the right-hand side, right? The gokrazy packer is the tool which both builds the image, like it bundles all of the programs that I tell it to bundle, and then it updates the image. So you can see it here, writing boot file system, writing the master boot record, writing the root file system. So that's the image generation. And then afterwards it says, okay, I'm updating this device over HTTP. And then it logs how quickly that happened, and then triggers a reboot, and that's how the firmware gets updated onto the new firmware gets updated onto the device. Okay, so the problem here now is that the maybe switch to inactive, this should not be using proc command line. It should be looking at the command line on disk, because in the phase where we switched from try boot inactive to switch on boot, that is not reflected in proc command line. It's only reflected on disk. So I suppose what we could do here is read command line. Yeah, I suppose that would help. Return the content and return an error. And then let's see, was there like a read function? No. So we would need to read it ourselves, but that's fine. So we'll just copy this entire thing here. And then we return the nil. And all of these return error will be return nil error. And that should read it from disk. So now instead of doing this, I'm going to do that. Okay, that should fix the problem. So go back to the standard update, and then we'll try a test boot afterwards. And remove this in the meantime so that we have a clean log file afterwards to start. Okay. Testboot update. Fingers crossed. Maybe it works this time. Okay, I mean, this looks pretty good. So it's saying this is the original init process. Well, actually, let me close the log and show you. So this line here is the original init program. Oh, we can even see it, right? We can see the build timestamp of the original one. Then it says switching to inactive root partition. You can see here the build timestamp. It's now the more recent one. This is 4807. Oh no, it's the older one. Oh. Okay, so this is 4846. This is 4807. So it's switching to the older one here. Why? We would have expected the opposite, right? It should be turning back time. Yeah, weird. It should be a newer one. See, this is why it's good to print a build timestamp so that you catch these issues immediately. But aside from that, like the handover process seems to work fine. I want to say we could do a quick examination of the system, but you know, we see our typical mounts here. Proc file system seems to come up fine. Processes seem to come up fine. There's no like extra processes hanging around or anything. So yeah, I think the general approach of doing the switchover works. It's kind of weird that it switched from newer to older. So I'll need to think about what's happening there carefully. But we're also running close to our time limit for today. So yeah, I guess the next step would then be to, upon success, remove the switch on boot one if it's found, and switch the inactive root partition permanently into the new version. So we already did Testboot handler. This one will maybe be addressed later. And that one is this component just redundantly captured. So let's remove it here. And we're going to change current plan, current status. And we're just going to go through a couple of the things that we did, review, and then push them out so that, you know, what we did today is committed and in the books, and then we can extend on that later on. So this is the internal refactor. Read command line could potentially also be refactored with modify command line to share a little bit more code. But what we did is refactoring of switch root partition, which now calls modify command line. This allows us to quickly define an enable testboot function, which does other replacements, but similar. So this would be testboot handler. Let's stage all of this. And this one here, we don't stage yet. Implement /update /testboot handler related to this issue. Okay, and then in here, we have a switch to inactive root, which is the mount change root, change dir exec dance. That kind of works, we think. That also works. Yeah, I think we're just gonna commit this as is. So this would be switch to inactive root partition. I mean, there's still the bug that it switches to what we think is older. We're also gonna make a note of this in the GitHub issue. If is set. To this one here. Just gonna push this. I think we still had changes in the packer as well. Yep. So, oh, and the updater as well even. So the updater one, Testboot marks the inactive root partition to be tested on the next boot and made active if the succeeds. Okay, so this is the updater function. Also related to this one. Let's push it. And then we're going to pull the new updater version into the packer, which currently uses the replacement version here. Tools. Say updater at latest. Paste this. Yep, that looks like our version that we just pushed. All right. And then let's see what changes we did. We did the padding, so we have enough space. We definitely need this. And the testboot one. Yeah, it's still a work in progress. Maybe we can think of a quick description before we push this. So let's do this first. Add command line with enough space for during update or during testboot file parameters related to this one. And then here, trigger a testboot instead of switching to the new partition correctly. And then, maybe later we can actually make this default to true so that all of the updates will be tested. But let's see first. I mean, first of all, we need to get it working properly, of course, but then we can see how it fares. So add testboot flag. Okay, cool. Push this one as well. Oh, see, this is weird. I don't see .git in here. I should be seeing it, I think. And even if I press Control L, it doesn't show up, but in here it shows. Strange. Okay, this, and then push again. Okay, I think that was all the repositories. We had tools, updater, gokrazy, kernel. We didn't need any changes after all. So, current status. Okay, discarded. Open questions / bugs. During testboot, switching to the inactive partition. Seems like an older build was started. And then we had these log lines here. Yeah. Cool. So this is the issue that we were seeing. And this is where we stand. Okay, yeah, I think that's going to conclude it for today. I don't know if I'm going to finish this on stream or off stream. We'll see. But thanks for hanging out today. And I'll catch you soon in another stream. Bye-bye.